Let's practice doing mole mass conversions. Example 1 is if you find the mass of a sample of glucose to be 90.0 grams, how many moles of glucose do you have? You can tell that this is a mole mass conversion because you start with mass and you are asked for moles. Anytime you're going between mass and moles, the relationship that you use in order to do this conversion is 1 mole equals molar mass. So this means we need to find the molar mass of glucose. So let's look at our periodic table. We have 6 carbon atoms, so we do 12.01 times 6 gives us 72.06. We have 12 hydrogens, so that gives us 1212. And we have 6 oxygens, so we do 16 times 6 to get 9600. When we add these all up, we get that the molar mass is 180.18. So now we know that 1 mole of C6H12O6 equals 180.18 grams of C6H12O6. And now we're just doing dimensional analysis like we learned in our first chapter. We start by writing down what we know. 90.0 grams C6H12O6. It might seem redundant to keep writing the molecule, but towards the end of this chapter we're going to be changing from one molecule to another, so it's good to go ahead and get in the practice of doing it that way now. And because we're converting units, we're going to multiply by a conversion factor. We've already said this is our conversion factor. If we want to get rid of these grams here, that means we have to put these grams on the bottom so that they cancel out. So we have 180.18 grams of C6H12O6, and on top is 1 mole of glucose. We can see that grams of glucose cancel out, leaves us with the units of moles of glucose, which is what we were asked for. We multiply by the top, 90 times 1. We don't actually have to put that in our calculator because we know that that's 90. And then we do 90 divided by 180.18. And the number you get out of your calculator should be 0.4995. Let's talk significant figures. Remember, when doing multiplication and division, your answer has to have the same number of significant figures as the original number with the least. So this number here has 3 significant figures because there's a decimal, because the decimal is present, so we approach from the Pacific, 1, 2, 3. This number here has 5. That means we have to round our answer to have 3 significant figures. That means we have to make these 3 numbers significant. This 5 rounds up the 9, so we get 0.500, and don't forget your units, moles of C6H12O6. And that's our answer with the correct number of significant figures. Let's look at a second example. It asks how many grams are in 4.5 moles of sodium oxide. And I've given you the formula for sodium oxide there. We know when we're doing mole mass conversions that we're going to do 1 mole equals molar mass. And I like to write down my conversion factor because it helps me remember it later. This means we need to find the molar mass of sodium oxide. So we look for sodium on our periodic table, and we get 22.99, and we have 2 of them. So we do 22.99 times 2, and that gets us 45.98. And we have 1 oxygen, which is 16.00. You'll find that the more you do these, the more masses you just know off the top of your head. So 1 mole of sodium oxide equals 61.98 grams of sodium oxide. And now we're just doing dimensional analysis. We start by writing down what we know, 4.5 moles sodium oxide. We're going to multiply by a conversion factor. This time we're trying to cancel out moles, so we will put 1 mole sodium oxide on the bottom, and we will put the molar mass, 61.98 grams of sodium oxide, on the top. Moles cancel out. We do 4.5 times 61.98 and divided by 1, which doesn't change the number. And your calculator will give you 278.91 grams. Let's talk significant figures. This number has 2. This number has 4. So we need to round our answer to have 2 significant figures. We cannot drop these numbers and round it to 28. We can't change the number that much. Remember, this 2 is in the hundreds place. It has to stay in the hundreds place. So instead we will put in an insignificant 0. So we'll say 280 grams of sodium oxide.